Okay, empirical rule. You hear empirical rule 68, 95, 99.7 needs to pop into your head. IQ scores have a bell-shaped distribution, mean of 100, a standard deviation of 15. This means 68%. If it's a bell-shaped curve, 68% of the data lies within one standard deviation of the mean, 95% within 2, 99.7 within 3. What percent have a score between 70 and 130? Let's look at what we're talking about with a bell-shaped curve. Here's my bell-shaped curve. The mean is 100, standard deviation is 15. So if I go down to 85 and up to 115, we're saying 68% is between these two values. If I go down 15 more to 70 and up to 130, that's 2 standard deviations above and below each way. So that says 95% of the data is between those two values. So that would be part A. Okay. B. What percent of people have an IQ less than 70 or greater than 130? Well, if 95% is in this range here, then that means over here and over here has to be the other 5%, right? Because it's 100% total. Okay, and then C, what percent have an IQ score greater than 130? Well, if this is symmetric, which we're assuming bell-shaped is symmetric, then we would have 2.5% over here and 2.5% over here with 95% in the middle. So C would be 2.5%. Does that make sense? All right, let's look at the next one, 32. Perico Rule again. The length of bolts has a bell-shaped curve with a mean of 4. So I'm going to draw the bell-shaped curve. U equals 4, and the standard deviation equals 0.007. And I'm going to put 68, 95, 99.7 up here. Okay, 68% of bolts manufactured will be between what lengths? Well, that's one standard deviation below and one above. So this right here is going to be 4 minus 0.007, and that's 4 plus 0.007. That's those values right there. Okay. What percent will be between 3.986 and 4.00014? Well, it happens to be the next one up. 4.014 is 2 standard deviations above. And if I go 2 down, that'd be 4 minus 2 times 0.007. Okay, that's what that number is. Okay, does that make sense? Okay, so I go up plus 0.007 plus 0.0707 minus minus. Okay, that's this guy right there, and that's that guy. If the company discards bolts less than 3.986, this number right here is 3.986. These guys over here are greater than these over here. This is like the last problem we just did. Or over here, what percent get discarded? Well, in between those two is 95%. So on the outside, it's going to be 5%. Okay. What percent will be between 4.07, that's this number here, and 4.021? Ooh, here is 4.021, because that's 4.07 again. Right? So here, let's do that picture again, because this is a good just adding and subtracting question. So here's 4. One standard deviation is 4.007. 2, 4.014. 3, 4.021. So they're asking what percent is in here. Okay. Well, I know if I go back, I'm going to go back this way too. I know from here to here is 99.7, and from here to here is 68. Okay. Well, there's a couple ways to do this. If I subtract those two, that's going to give me this amount here, the percent between 4.007 and here, plus, okay, don't know why I just did that. I probably don't know how to get rid of that either right now. Here, let me see, pause it. Okay, apparently I just added a text box or something there, and without putting my keyboard on, I can't do it off the top of my head here, so live with it. So, sorry. I said live with it, that's me, live with it. So 99.7 is between this value here and this value here, and 68% is between here and here. So if I subtract those two, let's do 99.7 minus 68, 7, 1, 3, 31.7. That's what percent is between there and there. And since it's completely symmetric, how much is between these two and these two? Well, let's divide by 2. So 31.7 divided by 2. 0.7 divided by 2 is 15.85. That percent of the population is between 4.007 and 4.021. Okay, so between those two right there. All right, there you go on that guy.